Okay, so let's talk through why we can get away with doing this, or a justification for this separation of variables. So this is a proof of sorts, not a formal proof, but pretty close. So let's start out with with a differential equation. It's called separable if it can be written in the following form. So dy dx is equal to g of x times f of y. So a function of x times a function of y. And then what we're going to do is we're going to let f of y be equal to 1 over h of y. And that's as long as f of y is not equal to 0. For obvious reasons, if it's equal to 0, we've got other issues going on. This means we can rewrite this as dy dx is equal to g of x over h of y. And then what we're going to do is we'll multiply through by h of y. Gives me h of y times dy dx is equal to g of x. Okay, so just a little bit of algebra so far. Okay, now what I'm going to do is I'm going to consider y as a function of x. So you saw something similar to this when we worked through a proof of integration by parts. So this will be a similar kind of idea. So if we consider y as the function of x, then y is equal to y of x. And dy dx is y prime of x. So I'm going to make those substitutions here. So I get h of y of x. I'll replace that dy dx with y prime of x, and that's still going to be equal to g of x. We haven't done anything to the right-hand side. Okay, so there's my rewritten form, and then I'm going to integrate both sides with respect to x. So I have the integral of h of y of x, y prime of x dx is equal to the integral of g of x dx. Okay, so both of those are with respect to x. And now I'm going to make a substitution. So I'm going to let y equal y of x, and then dy is y prime of x dx. Okay, so very similar to that U substitution process. A little sticky wicket because we're doing this y equals y of x. Okay, and we're kind of reverse engineering what we did here a little bit. So this is going to give me the integral of h of y. And then this whole piece gets replaced with dy is equal to the integral of g of x dx. Okay, and as long as we can find antiderivatives for both h and g, then we're going to have an analytical solution to this. So we'll be able to get our solution curve and graph all of that. Okay, so hopefully that gives you a little bit of insight into kind of why this process works or how we can get away with using this process. So this isn't a formal proof, but it's a good justification for why this works out.